Hello. This afternoon, I sent you the previous homework. Let's talk about that first. Now, I think it's a very basic exercise of indefinite integrals. I want to point out that I think at this stage, you should show this step. Because you know that you're taking out a factor and that's needed. And also you are applying this formula. Unless it really is very simple. In this case, n is -3/2. And naturally, I think you need a few steps to work it out. You need to work out the coefficient. You also need to work out the index. So maybe you show this. Show this. And also maybe not the ones who are present today, but for those who are watching the video, the integral of 1/x dx, the outcome is log x absolute value. This absolute value sign is not optional. If you don't write it, it's wrong. It's not like, oh, a small mistake. It's not a small mistake. It's wrong. Okay, so you must add that. And for the last question, 40b. For 40a, you can get integral of 2x cubed x4 plus 1 dx equal root x4 plus 1 plus c. And then you can get this one. If it's not very clear, I hope this makes it very clear. So at first you have a 2 inside, and then you don't have the 2 by dividing 2. I hope that's all. That's all for the previous homework. It's a long time ago. I only marked it today, so I remember it vividly. Maybe you need some time. Now look at 7.3, the updated version. Now last time we went through a little bit, and I wasn't feeling very well about that. I mean, I don't feel that I have explained enough, because this part is very tricky. It may be the most difficult part in the integral technique, is the integration by substitution. Now, first of all, the theorem is difficult to explain. Now, you can see something equals something equals something equals something, but eventually you will see that at first you have something about x. I hope it is about x. This is something about x, and eventually you're going to change it to another variable that's u. So in order to do that, you need to figure out how to change it. And here I try to demonstrate a few examples, but I don't think that's enough though. I don't think that's enough. So today let's try it again. Let's try it again. I will explain another approach to try to make this easier for all of us. So listen, listen. Example 7. Example 7. I think last time I also explained this, but I don't know. I don't know. And for this question, you must know that I cannot find the integral directly. I don't know if you understand. I cannot find this directly because none of the formula apply. I mean, the formula we've learned, none of them apply. Now, this one, in order to do that, I need to get rid of the structure here, which is square root, that's not good. And then also 2x plus 1. It's not the best, not the best. So my substitution will be, let me think it through. My substitution will be, let u be 2x plus 1 for A. Let u be 2x plus 1. Now, so that you can see that the function can be changed to a function of u directly, because this will be root u. However, here dx, this dx has x in it as well. So what you do is you must change dx to du, but ds is not equal to du. They're not equal. Now you need to work it out through differentiation, work out the relation between u and du and dx. And this is how you do it. This is how you do it. You can use the substitution you just created, and then you try to find the derivative. Not du dx, sorry. Du dx. Okay. And that will give you a relation between du and dx. You can say du equal 2 times dx. Now, right now, you need to treat it as a fraction. Right now, it's something divided by something. It's not a fraction, but it's a limit of a fraction. So technically you can do that. You can do that. And also, because I need to change dx to du, so I will change it to dx equal 1 over 2 du, so that my substitution can be completed. So this integral 2x plus 1 dx now is equal to root u times 1 over 2 du. Now I highlight the part that I changed. This one is root u, and dx is 1 over 2 du. Okay, as long as you get that. And then I can somehow use the u 1 over 2 du. And this one is one of the formula applies here. That is the power rule. And then you simplify it. Now you calculate, this is the final coefficient, and then you write u back to x. And then you're done. Is that okay? I think last time, because I tried to get the short version, out of it too quickly. So I skipped this part. Now, this time let's do it like take it on. Like this is most difficult part, but we try to do it the proper way. This is the proper way with the substitution. Now, I'll show you again. Show you again for part B. For part B, I will have another substitution. You will see. I will let u be 1 minus x squared. Okay, so that you can see that, oh, I can change this to u to the power 8 instead of 1 minus x squared to the power 8 instead of that. No. However, I still have x and dx, the two parts. Those are difficult to change it to u, but somehow I will do so. I'll do so. Now look carefully. So I will find the derivative du dx, which is negative 2x. You need to do differentiation. And then because of the differentiation, you will find a relation between du and dx. Now you will get du equal negative 2x times dx. Okay. And then you remember that we had trouble with x and dx. Now here inside it has x and dx. Now I can find x times dx, which is x times dx equal negative 1 over 2 du. You see? Okay, so it works out like perfectly when I change this to u, 1 minus x squared to u, and then when I have to deal with x times dx, it just works out so perfectly that x times dx is equal to negative 1 over 2 du. So in my substitution, in my next step, I would get rid of all the x, and then I will only have u left. Now you see. So this integral, x 1 minus x squared to the power 8 dx. Now I can first switch the order. So I'll put the power 8 first, and then x dx. I just swap them. And then I will change this to u to the power 8. And this part will be negative 1 over 2 du. Again, this is this, and this is this. It has to work out perfectly. Now, let me be very frank with you. Now, if this x dx does not work out perfectly, that it still has something left, then that's called the substitution is not successful. A successful substitution should work out just fine, that everything gets replaced and you have a whole new set of variables. You cannot have a mixture. What I mean is you cannot have x and u at the same time. That doesn't work. So now you have u only, and this one is an easy one because remember, this is not u to the power 8 minus. This is u to the power 8 times. So I will take out negative 1 over 2 and u8 du. And that is equal to negative 1 over 2 times 1 over 9 u9 plus c, and negative 1 over 18 1 minus x squared to the power 9 plus c. Just as the previous, as part A, in the end, I have to change the variable back to x. So it's completed. Okay. Now I'll explain more. I'll explain more. Classwork. Instead of last time we didn't have classwork, This time we'll do classwork. I'll show you. Instead of you working on your own, I will show you how to do it, because I don't think there's enough example. I show you more example, as many as possible. I need a substitution, which is u equal 3 plus 5x, and therefore du dx equal 5, du equal 5 dx, dx equal 1 over 5 du. Now this part, like I said, you're just pretending this derivative is a fraction. You're doing that. And then the integral 3 plus 5x to the power 6 dx is equal to u to the power 6 and then 1 over 5 du. And the substitution I want to show you clearly is the yellow part is replaced by the yellow part, and the blue is replaced by the blue. Is equal to 1 over 5 u6 du, and then 1 over 5, 1 over 7 u7 plus c, that is 1 over 35, 3 plus 5x to the power 7 plus c. Part B. Let u be 3 minus 4x. And later on, you will learn that there are multiple substitutions that could work. But this time, I'll just use the simplest one. Du dx equal negative 4. Du equal negative 4x. Negative 4 dx. Dx equal negative 1 over 4 du. Therefore, the integral is equal to square root u negative 1 over 4 du. Again, the substitution is the yellow part and the blue part. So it's equal to negative 1 over 4 u 1 over 2 du. That is negative 1 over 4, 1 over 2 plus 1, u to the power 3 over 2 plus c. And then you need to work it out. It's 1 over 6. U is 3 minus 4x to the power 3 over 2 plus c. Last one. Let u equal x squared plus 1 du dx equal 3x squared. Therefore, du equal 3x squared times dx, and also x squared dx equal 1 over 3 du. Now you try to follow me. Because I don't think this method I'm trying to show you is the most intuitive. Maybe some other teacher may tell you something different, but I try to make it very, how do I call it? It really is very math. It really is very math, and I tried not to put x and u in the same expression. Now, if I change to u, I will change all at once. I will not make a mixture. Now, some other teacher may not do that, but I hope that you can try to get the idea that when I try to change to another variable, I don't change this part and keep the other part. I don't change this and keep dx. I don't change dx and keep this something. I don't make a mixture of those. And you try to do the same, because I mean, in the end, maybe not now, but in the end, you have to have this idea, this technique, or this ability to get rid of all the variable that you do not want. So you can see it's very weird that I have this put in one side, this part, because I'm going to replace it. You will see. So this is x squared, x cubed plus 1, 4 dx. To make it, sorry, I need to. And then x squared dx. Now, at first, I will try to separate them. I mean, I switched the order so you can see they can be separated. It's u4, and this one is 1 over 3 du. And you can see the replacement. Now, this part is changed to u. And this part is changed to du. One moment. Sorry. And then it's 1 over 3 u4 du, 1 over 3, 1 over 5 u5. And in the end, it's 1 over 15. 1 x cubed plus 1 to the power 5 plus c. Okay. Anyway, this is the hard way. This is the hard way. Now, when you randomly choose a substitution, I think right now you will feel, oh, the substitution is completely random. When you randomly pick a substitution, and then everything has to work out just fine. And it should work out just fine. Okay, we'll move on now. Move on. Example 8. This one, I think last time I showed you 2 different substitutions. This time I will do it again. Do it again. So the first one, let u be x plus 2. This is the easiest one. So we know that because of that, therefore du over dx equal 1, du equal dx. I think that's the easiest, du equal dx. So the substitution is very easy. You just, this integral is changed to u minus 1, u minus 2, square root u times du. Now this part is this. This and this. Okay. And this is u3 over 2 minus 2 u1 over 2 du. Now sometimes I put a bracket, but sometimes I do not even put a bracket, but you know, there's a bracket. So this is 1 over 3 over 2 plus 1, u5 over 2 minus 2, 1 over 2 plus 1, u3 over 2 plus c, and then you work it back. U is x plus 2, 5 over 2, plus minus 4 over 3, x plus 2, 3 over 2 plus c. Okay, and then you're done. Now this one is easy because the substitution, I think the u equal x plus 2 is very easy because in that case, du equal dx. Second. Now what if I don't use this one? Another substitution that you can make is u equal square root x plus 2. I think. Yes. Yes. But this time, I don't know. If I use this substitution, what should I do in order to make like that? You must know that my final goal is to get rid of everything. Get rid of everything. How do I do that? If I do du dx now, I will get 1 over 2 du. That's not very good. Now, if I do d if I do du dx right now, and that will have 1 over 2 this. And that's not very good because I don't know how to replace it. You know what I mean? Now, if I do this, and then I will have to do it the other way. I have to do du equal 1 over 2, 1 over root x plus 2 times dx. And then this will be back to x again. You know what I mean? I guess it will work. It will work, but it won't work so seamlessly. Now, if you do this, that means dx equal 2 times root dx plus 2 du. Right? But in my replacement, I have to change dx to completely u, and x should not stay. You know what I mean? So here, if I do this, it won't work out so perfectly because I don't want this to stay. So I will do an extra step in this case. I will do dx equal 2u du instead. Now here, because I have x, and I will change the x back to u again. And that will work. That will work. Now this time, now you must know I'm still trying to get rid of x. And the difficult part is dx. Now I changed dx back to this, and that's not enough. But in the previous examples, it just worked out. But for this one, it doesn't work out completely because I cannot have this around. And then I have to change it back to u. Sometimes that's needed. So you do that, and then your integral will work out. This one is x x plus 2 dx is equal to, now here x is u squared minus 2. And this one is u. And dx is 2u du. Okay. Now this one I'll highlight because this part is this. Right? And then with dx, sorry, with dx, it's this. Yes, yes. If I do that, and I have this extra step, let me highlight. This is the extra step we've never done before, but you will do that in your exercise. You will do that very often. So this part is extra, but you have to do it. No, you have to. Otherwise, you have an x in it. Imagine if you put this part inside, you cannot do the integration later on. So with this completely changed, you see, because I've done so much preparation that my substitution is successful. When I have all things moved and then I have only u left, and this is an easier function. So this is equal to, take out 2, that's u to the power 4 minus 2u squared du. And that is 1 over 5 u5 minus 1 over 3 u3 plus c. And then that's 2 over 5. U is square root x plus 2 to the power 5 minus 3 over 2 square root x plus 2 to the power 3. 2 over, it's 4 over 3, sorry. 4 over 3 plus c. The answer is the same, you see. If I use the first substitution, obviously it's easier because in your substitution you don't have a square root, then the relation du dx is easier. But this one, du dx is more difficult. Du dx more difficult. So this replacement is more difficult. However, now because this difficult part, the integration part is easier than this part, because this one you have fraction and this one you don't have a fraction. I hope that's that's the difference. Okay. So I think last time I did, but then we did the first one. We did the first substitution, but we didn't do the second substitution. At this time we did the second substitution. Now you can see the difference. The classwork, I'll show you again. I'll show you again. Now, please try to stop me if I'm moving too fast. This one. The first substitution, u equal x minus 3. Then du dx equal 1. Du dx equal 1. Du equal dx. Now you can write it backwards, dx equal du, just for convenience. Because in my substitution, I'm going to change everything. First one is x squared. The x squared is u plus 3 squared. That's x squared. And this is square root u. And dx is du. Okay. And that is u squared plus 6u plus 9 u 1 over 2. And that is u 5 over 2, 6 u 3 over 2, plus 9 u 1 over 2 du. Now you should put a bracket. Now sometimes I just don't. And this is 1 over 5 over 2 plus 1, u 7 over 2, 6, 1 over 3 over 2 plus 1, u 5 over 2, plus 9, 1 over 1 over 2 plus 1, u 3 over 2 plus c. And the answer is 2 over 7. U is x minus 3. 7 over 2 plus 12 divided by 4, that's 3. U x minus 3, 5 over 2, and plus it's 18 over 3, that's 6, x minus 3 to the power 3 over 2 plus c. The answer. Okay. Now this part I know it's long, but technically this part is just some basic integration. It's long but basic, and your substitution is done in the first two rows. Second substitution. Now second substitution, I have to again do du dx. Du dx. So du dx equal 1 over 2 x minus 3 to the power negative 1 over 2 dx. Sorry, no dx. Like that. Therefore, du equal 1 over 2 times this dx. Therefore, dx equal 2x minus 3 du. Like I said, no, this is not enough. Not enough. You must change it to 2u du. And then your integral can work out. X squared, x minus 3 dx. Right now, it's x squared. Now first x squared is u squared plus 3 squared. That's x squared. And the second one is u. Okay. And then dx. dx is 2u du. Now here you may need some time to work this out. This part is x squared. Because technically you need to work this out. It's u squared equal x minus 3. So x equal u squared plus 3. All that. All that. And then this part. And then this part. Everything. Everything. Now because you did that, I think it's a little bit easier with the integration. This is u4 plus 6u squared plus 9. This is 2u squared du. That is 2u6, 6u4, 9u squared du. That is 1 over 7 u7 plus 6, 1 over 5 u5 plus 9, 1 over 3 u3 plus c. And then I think I read it here, it's easier, it's 2 over 7 u7, that is root x minus 3, 7, plus, oh, that's not the same. Am I crazy? Why is it 3? 4. 6. 5 over 2. Why is it 5? It is 5. Oh, I think I got this wrong. Huh? Sorry. It's 12 over 5. This is 12 over 5. 12 over 5. So here it is 12 over 5. That's correct. 12 over 5. X minus 3 to the power 5. And the last one is 6. Yes, last one is 6. X minus 3 to the power 3 plus C. You see, again, you have the same answer. Okay, is there any question? Nobody? Because if you have any question, you should ask now. Otherwise, in the next example, we will try another way. Try another way. No matter how difficult you think this is. Do you follow? Let me ask one student. Sophie.
Yes, I can follow.
Okay. It's really not fair. It's big because Sophie follows, so everybody follows. Does it work that way? Anyway. I know you may think, oh, does it take so long? Yes. Integration is more difficult than differentiation. It should take long. I think at first, if it takes you longer than usual, that's fine. Because the ultimate goal is that later on, after a few months, you can integrate faster. I think anybody who anybody who has gone through this process of integration and in the end has mastered the technique should tell you that this takes a lot of practice. It really is. In my time, we are talking about, because my teacher also, in my time, we're talking about 6 books, 6 exercise books, so that you can say, okay, I'm quite comfortable now. I think for you, it's at least 300 exercise, like even the same one, like repeating, because this is not easy. This is not easy. Anyway, now this is the hard way. This is the hard way. In my next example, I'll show you the short version, but still have this concept in mind. You must have this concept in mind that you have another variable, but you do not show it. It's kind of like chain rule, but backwards. You will see. Do you remember in chain rule, we at first we have this U thing, and in the end we just get rid of U. We just don't show you that there is another variable, but when you're doing it, you're using the concept of another variable. And this is the same. Now, right after this, because this, you can still see the variable. You can still, see, I'm using this variable, I'm replacing it, and then sometimes it works out just fine. But in the next stage, I don't know, you try that. We just skip that. Let's skip that. This is called the short version. Also in the textbook, I think we follow the same approach. At first, you do the hard ones that you actually use the variable. Now you just don't use the variable. Look here. In this question, how do I integrate? So you'll follow this 6, 3x plus 5 to the power 4 dx. Now, the first thing we do is to take out 6. I think we all know how to do that. That's fine. You can take out a variable. You can take out a thing. Now, sometimes you may see other teachers show this, like not writing in this way. They actually write 6. They put dx there, and that's fine. Now, sometimes I don't write 1 over 3x plus 5 to the power 4 times dx. I write dx divided by. It means the same thing. Now you must see this as a fraction. It's the same way that how we use the symbol says we're using it as a fraction. It's the same thing. Anyway, at the beginning, I'll show you this way. It's separated. Separated. This is a function and this is a symbol. Anyway, now right now we cannot integrate yet because none of the formulas apply. What you do is, I think last time I showed too quickly. It's this to the power 4, and then I will change it to 1 over 3 d 3x plus 5. Now this is the thing. This is the thing. Now, you must know that here I have u, and u is 3x plus 5. That's u. This is u. And dx is changed to 1 over 3 du. It's just I don't write it that way. It looks like, in my presentation, it looks like I am multiplying through 3 inside and dividing 3 outside. It looks like that way. Inside I'm multiplying and outside I'm dividing. Looks like I'm just cancel each other out. This whole just not, I did not change anything. And also last time I explained that adding 5 or subtracting anything, adding anything would not change this value. Because now you think about it, this is just du dx equal 3. Now, in the end, this is u. That means dx equal 1 over 3 du. That means du equals 3 dx. That means du dx equals 3. So this is the short version of what I call. It looks like you're multiplying or dividing. Looks like that. And then you can think this is 1 over u4, 1 over 3 du. Now I'm taking out 1 over 3 and make it 2. And that is something to the power negative 4 d something. Now this is not x anymore. This is u. This is u to the power negative 4 du. Okay. Now it's the variable has changed. The variable has changed, but I don't use it. I don't use it. So this can be done this way. So 2 negative 4 plus 1 and 3x plus 5 negative 4 plus 1. And then my final answer is negative 2 over 3, 3x plus 5, negative 3 plus c. That's the short version. But do you see? You use the long version and to compare. Because this is the long version. Look here. This is the long version. That's a similar question. It's a similar question. I changed dx to 1 over 5 du. But here, I do not do that. I do not show that. I show you dx is changed to 1 over 3 d 3x plus 5. But I hope that you realize they are essentially the same. but with understanding, with understanding. I'll show you more. Show you more. A, this short version, 2 minus 5x, is very useful, because this one I will get negative 1 over 5 d 2 minus 5x. Now it looks like I'm multiplying negative 5 and dividing negative 5. So it's negative 1 over 5, 2 minus 5x to the power negative 3, d 2 minus 5x. Okay, it's another variable now. It's another variable now. And then it's negative 1 over 5, 1 over, and 2 minus 5x. And then in the end, it's 1 over 10, 2 minus 5x to the power negative 2. It definitely is quicker. Definitely is quicker. There is my substitution. Another example. There is my substitution. It's done so seamlessly. I think right now you can at least do this, and later on you may do like more complicated ones. How complicated, I don't know. I don't know. You will see. You will see. Right now you must know, oh, I'm multiplying and dividing, and later on you will see more. You will see more. Do you have any question? No? Okay. Okay. Continue. Because I think that you guys, I think maybe you are fine, but the girls who are watching the video, they can pause it anytime. Example 10. This is what I call more complicated ones. Okay. Now, also with these, you may see this example before, but previously I did with the substitution, and you can see the another variable used. It's a similar question, but this time I will do it without showing the other variable. But I actually did use substitution. I look here. So this integral x4 and x5 minus 2, 8 dx. Now first, I will notice that the number 4 and 5, they look very suspicious. So I will do a swapping the order. I will put x to the power 4 next to dx. Because later on you will see my substitution. You will see my substitution. This is my substitution. This will change to, do not laugh. This is 1/5 dx5 minus 8. Fine. I think previously you did the multiply 5 divided by 5. I think that's easier, but this one, I'm not multiplying anything or dividing anything. It's not that. This one is with the knowledge of knowing what the differentiation could be. Now this one, basically I did the differentiation in my head. In my head. This is because I know that in your head or in your rough worksheet, at least you must realize that dx x to the power 5 minus 8 is 5x4. Okay. That's 5x4. So that means if you do this part, if how do I say it? I mean, x to the power 4 times dx must be d this divided by 5. Do you see? It means dx5 minus 8 equal 5x4 dx. That means 1/5 dx5 minus 8 equal x4 dx. It really is a lot of, now this is much harder than multiplying and dividing. This itself is an integration. It's like a small integration in your head because you are you're working backwards with the differentiation. You see, I have the differentiation and this. So I have this replacement. But it gets easier. It gets easier because later on you will put something else in it. Now x4 dx. Now it's like integrate. You have x5 minus 8 divided by 5. Am I crazy? I think so. I think so. I think maybe this is easy. Sorry. Maybe it's easier this way. Maybe I don't do the minus 8 this part. Maybe I just do this part. I think it's easier this way. If you do, I think it's easier to get x to the power 4 dx is 1/5 dx5 first. And in my next step, I can change it. Maybe it's this way. This is easier, maybe, with 2 steps, maybe. Yes, -2, not minus 8. -2. Maybe it's easier this way. Because -2 should not change anything. This and this should equal. Now, how do you see this part? Now this is like an integration now. x4, it's an integration, so you get x5 divided by 5, right? And then you can do the differentiation. Sorry, integration. You take out 5, and then x5 minus 2, 8, dx5 minus 2, and that is 1/5, 1/9, x5 minus 2 to the power 9. And then in the end, it's 1/45, x5 minus 2 to the power 9 plus c. Is that okay? So this integration by substitution is done in this very subtle way, you see. In the end, I did replace the variable. I did replace the variable. I didn't show it. With the next one. With the next one. This one. This one is. I think this one is more difficult, but more obvious. Now, when I do it, you will see where it's coming from. Now, this one, you copy it again. X squared minus x plus 3 dx. And then, again, I will separate it. This one, x squared minus x plus 3. And then this is 2x minus 1 dx. Okay, I'll put these two together because I will replace this with another variable. And this is, I think this is a very good example. This one will become dx squared minus x. Now think about it. This is doing differentiation backwards. Now, dx squared is 2x, you see? Dx squared is 2x. That's why I put it back, it's x squared. And then dx is 1. So if this is minus 1, that's x. Now, basically, it's that in your head, it's dx squared minus x dx equal to x minus 1. Now, basically, it's that backwards. So this way it's integrate to x. Perhaps I should use the term. It's not now. It's not this backwards. It's integration forward. So 2x integrate is x squared, and minus 1 integrate is negative x. So that's what it is. So this substitution, although more difficult, but I think it's more obvious. You will see what I'm doing now. And then obviously that's not enough because I need x squared minus x plus 3 to the power negative 1 over 2. And this one I also need plus 3. So I'll just add plus 3. Okay. And then I can do my integration. In the end, it's 2 root x squared minus x plus 3. Okay. I really hope that I have shown enough. So this classwork you will try on your own. And I need to see it though. So can you send me a message after you're done, please? Just a WhatsApp message. With this classwork, send me a WhatsApp message when you're done. I'm waiting a little longer. You must do it. You must. MA. Yeah. You're still using the U thing. It's fine. It's fine. But in the end, I hope that you don't. Because what you're doing here is a mixture of X and U. It's not wrong. That's not wrong. But our classwork here, later on, when I show you the answer, you must see that I don't have U. It's there, but I don't use it. I don't use it. Cindy, can you send me a picture of your working, please, Cindy? And Iris also. Yes, it's harder. Iris, you you haven't changed. You haven't changed. But it's correct. It's correct. Cindy, can you send it? Can you send your working to me? Are you using your phone, Cindy? I mean, for the lesson? Plus C, Cindy. Plus C. Plus C. Named. But excellent. Excellent. I think you're doing it very well. You're doing very well. Should I wait more? Catherine, Donna. That you can later on. You can keep working on this. I'll show you, Catherine and Donna. Now look here. Now this is how you were supposed to do without you, Bay. Now this is what you do. You look at the most difficult part. This part. You must change this to this. In a way, it's like you're using the integration. In a way, it looks like this. You're doing this. In a way, it's like this. Because here, x to the power 5 dx must be replaced with 1/6 dx to the power 6. That's what it's supposed to be. I know if you use u, then that will be du. This will be du. But that's not the short version. The short version. And later on, I will add 1. I think Cindy worked very well because she did the directly. Now, if you get this and then you add 1 will not change anything. I just add 1 and then you have this variable because you want x to the power 6 plus 1. And then this is the answer. Now all of you get the correct answer. Now Iris, you must learn this as well. You must learn this as well. Screenshot, screenshot, and learn this. Okay. Now similarly here, in the second part, now you see I will integrate x squared dx. And what does x squared dx equal to? Now, here. Yes, Donna, I know that now. Now, this part, x squared dx is equal to this. It's just like x to the power 5 dx is 1 over 6 dx to the power 6. Similarly, x to the power 2 dx is 1 over 3 dx cubed. Okay, it's like integration. This is integration. Because backwards, it's when I say, oh, you're doing differentiation backwards, that means integration, right? So integration, and then you need to do more, because this one you still need a 2. So that's why here I will multiply 2 and divide 2, you see? And then the -1 is just added. And then this is the end. Negative, I think it's negative, all right? Some of you got positive. It's negative 1 over 9. And this plus c, plus. So you've got a little taste of integration now. If you do it well, you will feel that this is how it is. This is how it is. And then right now, if I tell you anything, you won't believe me. You just need to practice. Now, for example, next time when you see x to the power 4, you must know that it's 1 over 5 dx to the power 5. Now, you always have this part, and then you get this part. X2, you must change to x3, you see? 2 becomes 3. And 5 becomes 6. Now, in my example, you can see 4 becomes 5. You see, 4 becomes 5. And here, this is 1. This is x to the power 1. So 1 becomes 2. 1 becomes 2. And the constant becomes x, you see? So it's like it's 1 degree higher, basically. Now, example 9, you don't have this problem. Example 9 is just the constant added, constant multiply 4 divided by 4. But for this one, I think the degrees changed. 4 becomes 5. You see this. You learn this. Okay. It's just so that happens. You see, this can be done because this is 5 and this is 6. Do you see? So that you must move the 5 inside, and then it becomes 6. It has to work this way. Otherwise, it cannot be solved. It has to work this way because this is 2 and this is 3. You see? That's the only way. That's the only way. I'll show you. I'll show you more example. More example of this. Now for this one, what you do is you do it 1 over 4. This is the easy one. Okay. And that is 1 over 4 e to the power u du. Remember, e to the power u du. E to the power u du. And the integral is 1 over 4 e to the power u. Okay, that the substitution happened here. This is the substitution. The blue part is just the integration. I'm applying one of the integration formula. Because before that, I cannot apply anything. This is not, because it doesn't work that way. Okay, for this one, remember what we learned? First, I will change the order, put x and dx together. And then remember that degree 1 will become degree 2. Now, May, you must learn, do you know? Now, degree 1 becomes degree 2. Okay. I know that in the rough worksheet, you can work that out, but you must gradually learn that this is just what it is. You must learn it this way, learn this way. And then it's 1/2 e to the power u du. And then this is equal to 1/2 e to the power u plus c. The substitution happened here. It's similar, similar. Now, every time I show you an example, I want to show you where the substitution is. Is it fine? Now this, I think that if you understand the previous example 10, you should understand this. It's just that here now I have another function, it's e to the power u. Wow, this is e to the power u, but previously I only have the polynomial. Now I have another function. Any questions so far? If not, I'm moving on. If not, I'm moving on. Stop me anytime. Stop me anytime. But the next one is a little bit new. It's a little bit new. This one, when I copy the question, I will also separate it into two parts. You see, I want to put these two together. Okay, I want to put these two together because I know that this is e to the power x plus 1. This is d e to the power x. That this is my substitution. This is new. This is new because previously we never done this. Now, do you know that e to the power x dx is de to the power x? Now, this is true because we know de to the power x dx is e to the power x. Therefore, perhaps I'm right. I write this part in red. I write this part in red. It's de to the power x dx equal e to the power x. Therefore, de to the power x equal e to the power x dx. Okay, that's my substitution. You see? I change it. And now I can change it to e to the power x plus 1 d e to the power x plus 1. Again, I'm adding 1 to it so that it will fit. Okay, it will fit my I have an objective basically. I have to plus 1, otherwise I cannot do it, because later on you know that because this part is 1/u du, it's equal to log u. Now remember, this is another formula. Perhaps you have forgotten. Right now you can use it. Okay? Because I changed its variable. Now the variable changing is right there. Variable is right there. Okay. Now this one, previously I said, oh, this absolute value must be added, otherwise you're wrong. But this time, because what we put inside is an exponential plus 1, and we have the knowledge that an exponential is always positive. Therefore, in this case, only in this one, the absolute value can be lifted. Only in this question. Because we know it's definitely positive. So you change it to a bracket. And that's called simplification. You simplify this to this. Because we know it's definitely positive, the absolute value sign is no longer needed. Then it's removed. It's not the same with this. This part, you must keep the absolute value sign because it cannot be lifted. But this one you can, because we know. Is that okay? Now you also know how the absolute value sign is gone. Otherwise, it's never gonna end. You always make a mistake. When you have sometimes you have absolute value sign in your answer, that's completely fine. No, that's completely fine. And sometimes you need to remove it. And this is one way to remove it. Any question? Part D. Part D. In part D, you will see another technique because this is equal this. Now you can see what I'm doing. I'm putting 1 over x and dx together. I'm putting these two together, and this is new as well. Because in my next part, this is this is my substitution. Now you might ask, how many are there? As many as there. I don't know, as many as the number of functions there are there outside. If there is a function, I can always do it backwards, you know what I mean? Now here, do you see what I'm doing backwards? I'm doing the d log dx, that's 1 over x. So 1 over x dx is d log x. I know. Unless you're very familiar with this, so it takes a long practice. Right now, during the lesson, I show you slowly. This is because we know that d log x is 1 over x. Therefore, you can do it backwards. Now, because you're doing backwards, that means integration. That this looks like integration, isn't it? Now, if you integrate 1 over x, you get log x. Now, if you do it backwards, the log, that's an integration. That's log x. Okay. So that is my substitution. This is my substitution. Now we need to continue. We need to continue. We're almost there, but here I need to remove the absolute value sign. And this can be done by realizing here in this question, x is positive. Now you write this. The absolute value sign is gone. Now, because this is what I write for you, you don't have to write it, but you should know that because in this question, x is positive. Now, you may say, oh, where does it say positive? It doesn't say to your face. It doesn't tell you, oh, do you know that in my question, x is positive? It doesn't say. It's very subtle. It's very subtle. Because in this question, do you see log x? Right? Because the symbol already implies that x is positive. Otherwise, the symbol would not make sense. The existence of log x implies that x is positive. This symbol tells you x is positive. Otherwise, what I'm doing here, it doesn't make any sense. So this is like, oh, like here. Now, if you, the symbol 1 over x implies x cannot be 0. Otherwise, what am I writing? So from what the original function is like, you should already tell that the range of x is already narrowed down to a certain, what we call domain. The technical term is called the domain. It's naturally narrowed down by the symbol which is defined that way. So in this question, we know x is positive and x cannot be 0, obviously. Otherwise, it's undefined. Therefore, the absolute value sign can be lifted. This is another case when the absolute value sign is not needed. When the question itself implies it's positive, then lift it. And then you can integrate. This is 1/2 u squared. And then you're done. Any question? Now the textbook ends here. The textbook ends here. But I show you one more set of examples with the same purpose. Example 11b. Usually I would not do exact 11b. This is 11a with the same like goal, learning objective, and 11b. It's another set, but with the same purpose. I'll show you again. And then you do the classwork, and then we're done. Very quickly. For this one, e -3 - 7 dx equal e -1/3 d 3x - 7. Oh, sorry, -3. -3x - 7. And that is -1/3 e to the power b, and that is -1/3 e to the power -3x - 7. Let's see. Okay, part B. X squared e x cubed dx equal x squared dx equal 1/3. You see? And then it's 1/3 e, and then it's 1/3 e. Okay. Now compare this one, and then this one. Yeah, 2 become cube. Square become cube. Square become cube. Next one. Ex plus 1, ex plus x, dx equal ex plus x. This is ex plus 1, dx, ex plus x. This one is dex plus x. Isn't it? Right? Ex, it's ex. 1 is x. It's integration. It put it in backwards. Okay. right? I think so. Now this one, I do not want to discuss whether or not this is definitely a positive or negative. Just leave it that way. Just leave it that way. Now some people would argue that, oh, this value is definitely positive. I think so. I don't think so though. Adding x. Sometimes maybe negative, right? When x is negative, it's negative, right? No. So do not really. This absolute value sign must stay because I have no idea what's inside can be. It can be positive or negative. You know what I mean? So this one must stay. Must stay. Next one. This one. Copy the question. I put them together. Change it to. Now here I will do it this plus 1. And then this is log x plus 1. Now this is similar to the previous one. It's 1 over x dx. Change it to log. But obviously I added 1. But that will not change anything. So here this is the substitution. And then in this question, now in this question, because x plus 1 is obviously positive, otherwise it won't be put inside log. The existence of log, again, the domain of what we're doing here already implies that x plus 1 is positive. So that's gone. That's the answer. Okay. Now, this time the classwork, I hope that you can do it better this time. And when you are done, please show me. Show me. Like last time. Show me. Now we have 2 minutes. I think we can have a look now. Some of you sent me your answer, and I think it's worth looking at. All of them are worth looking at. This is Sophie's answer. She sent me the first. Now I would say that, Sophie, next time you need to add a bracket here with the -1/5. And here plus C in the end, part B. And this one, she did it very slowly, but it's correct. The answer should have an absolute value. And with this answer, some of you got a different answer. I want you to look at it. You see how she did it? She got the log x. Now some of you separated 5 and log x. Later on, I'll show you. But what she did is to plus 5 here. And then she got 1/4 bracket 5 plus log x whole square plus c here. Remember plus c. But that's correct. That is correct. Here that adding 5 is correct. Adding 5 here is correct. Whereas if you look at another answer from, let's say another answer from, who's this? This is, I don't know. This is what do you call it? I don't know how to turn it. I have to download. Maybe I'll download. And I turn. How do I turn? How do I turn? Save as, pause, share, full screen. How do, here, sorry. I turn it this way. Yes. Cindy, the absolute value sign. She obviously, Cindy does it quickly, like the one, just in one step she did the this part. But here, Cindy, here you don't have to add C here because the differentiation is not done yet. This is still indefinite integral. In this part, still indefinite integral. So you don't have to add C. But after you've done the integral, because this is one specific integral, and this integral plus C. But the indefinite one, you don't have to add C because of this one is indefinite. So this one should add an arbitrary constant C. So this C is not needed. Here, this C is not needed either. This C is not needed. And that. Now here, this is what she did. That for part D, this is what I was talking about. You see, Oh, no. She did the same thing. She did adding 5. Cindy, please remove the plus C. Plus C, not needed here. Only here, plus C. She also did adding 5. She also did adding 5. Looking at, I think there, why did you delete all your answer? This is also adding 5. But May does it very quickly. Now, I think you did, May, you're doing it very well now, because in the first question, you're still using U. And later on, U is gone. That's correct. Because in your head, you still have U, but you can, you don't write it. You must learn how to not to write it. That's correct. That's correct. I was looking at, I think it's Sophia's answer, maybe. Sophia is very short. But this is what I mean by you have 5/2 and log x separated. This is what I mean by that. Now, Sophia, you should look at Sophie's answer. And Sophie, you should look at Sophia's answer. Both of you are correct. You hear? You see, it's separated from, this is one term, this is another term. And then you just integrate each term, and then this is the final answer. Now, whereas Sophie's answer and all the May's answer and Cindy's answer, it's not separated. Let's look at May's answer again. Do you see? Now, 5 and log x are not separated because she did adding 5. This is not clear because she read. You wrote too few steps. Let me see what Sophie did. Sophie showed more steps, but May, you should look at Sophia's answer as well. Sophie's answer. Now, Sophie, if you choose to here in this step 5 plus log x d log x. Now, if you here you choose to separate 5 and log x and do the integration separately, you will get the same answer as Sophia. But you didn't. Instead you get this answer, and Sophia got another answer, and your answer are equivalent. Both are correct. Is that fine?
I'm sorry, Ms. Chen. I don't really understand how to separate two of them.
What do you mean?
Like, I don't know how to separate 5 plus natural logarithm of x.
Oh, I don't mind showing you again.
Thank you.
Let's say in the steps, you will have 1/2 5 plus log x d log x. In the step, you have this, but instead of adding 5, you will just do this. You will do 2 integration separately. This is what Sophia did. He did it separately. So this will be 1/2 times 5 log x. And this one will be 1/2 times 1/2 log x whole square plus c. This is integrate 5 du. So it's 5u. Well, this one. This is integrate 5u equal 5u. This one is integrate u dx, u du, sorry, u du. And that is 1/2 u squared plus c. This is what I mean separately. You see? Here and here. A different answer. A different answer. This is Sophia's answer. 5/2 log x plus 1/4 log x squared plus c. Your answer, the other three, I think Iris also get this answer, but I couldn't see it now. The other three, you got the something bracket square. Because you integrate, that's because you add 5 here. Whether or not you choose to add 5 here, that changes the next approach. You change the approach, but this is what it is. Okay, and Sophia, you should also look at this is Sophie's answer. You see, it's not separated. It's one gigantic, it's a whole square. And in the end, your answers are equivalent. Okay, that's all. That's all. We overrun. I'll see you tomorrow. I'll see you on Tuesday. Bye-bye.
Sorry, Miss Chen, I have one more question regarding chapter 4 of M2. Like if I write limit x tends to infinity, then I write 1 over square root x, then can I simply say the answer is 0 because when x tends to infinity, then square root x will also tend to infinity.
Say again, 1 over root x.
Do you mind if I write it out?
Yeah, sure.
Sorry. I'll send you the message. For this question, can I simply write 0 as the answer, but not explaining why